welcome everybody to our SDGnexus Network colloquium seminar. So I'm very happy to welcome for the seminar today our colleague Begaiym Emileva from the University of Central Asia, standing next to me here, who is our speaker today. Begaiym is visiting the university and joined for a couple of weeks. And Begaiym, you are also a research associate with one of the SDGnexus Network core partners, right? You have been working with them since spring this year. And today we have the chance to hear a bit more about your ongoing research, about the research plans. What is your research focus? I'm welcoming everyone online, also in the seminar room here. Happy to see many familiar faces. And without further ado, I will hand over to you, Begaiym, please.
Today, I would like to talk about climate risks and adaptation strategies in Central Asian agriculture at TEU colloquium. And let me start. So in this topic, I would like to talk mainly two topics that are interlinked to each other. So first one is the climate risk effects on dairy production in Kyrgyzstan. And the second one, the role of farmers' perception index insurance demand in Kyrgyzstan and Uzbekistan. So why these two topics? Because these both topics are very quite interlinked to each other, and they are also quite relevant in terms of climate change in Central Asia, and both topics are also includes climate risks, which I'm working on those topics. And these topics are also kind of contributing to sustainable development goals of UN. So especially for land use, for example, or like climate actions, poverty reduction, and so on.
Sure.
So here the general introduction about climate change in Central Asia. So here we see on the right side annual mean temperature starting from 1950s to 2023, I think, and also the precipitation changes from 1950s to 2023. So here we can see two countries like Kyrgyzstan and Uzbekistan. So here we see the season or the annual fluctuations of temperature and precipitation, which kind of shows also the trend. Like in the past, let's say 100 year or past century, we can see that slightly increment in temperature, and also we see the fluctuation of precipitation. So we unfortunately don't have seasonal graphs here. Then if we had, I think we would. It would be better to understand the seasonal changes of these trends. So so now I would like to talk about climate risk effects on milk production in Kyrgyzstan. So as I said in the beginning, so I will be talking about two topics, this is the climate risk effects on milk production in Kyrgyzstan. This is actually that I'm working on this topic in this SDGnexus project. So we can see in this picture that was taken by Martin Petrick, and they borrowed the picture from him. So we see the mountains and also the grazing and also the livestock here. So this is how the livestock system is looks like in Kyrgyzstan, because Kyrgyzstan is quite a mountainous region, and the livestock was a part of smallholders or the people's lives. So Kyrgyz people are also kind of nomadic in nature, as they have been always closely worked with the livestock and also dairy products and etc. So why we decided to work on milk production? Because this, as I said, livestock production is quite very important for smallholders in Kyrgyzstan, and also it's especially the dairy products or like real production is also like on the daily on the farmers or the people's daily menu, I would say. And climate the milk production is also like essential to income for smallholders because they get they sell and they get money from milk, and also it's like a kind of like food security for like smallholders in Kyrgyzstan. So unfortunately, like livestock system is also kind of affected by climate changes, as I mentioned. Like this, it could be also high high temperatures. It could be also drought or like rainfall, and it's also directly affects the milk production, so through the fodder availability. So this research statement, like the problem statement, brings us to the research gap, which is which we found that there is not that much empirical research actually on climate risks, on fodder production, and consequently on the milk production in Central Asian context, and especially in Kyrgyzstan. So this research gap actually brings us to two research questions. First is how drought, excessive rainfall, and temperature affects fodder production first. And then the second one, how the fodder production affected by drought or excessive rainfall and temperature affects total milk production. So, and for to analyze these research questions, or to answer to these questions, we will use Kyrgyz Integrated Household Survey panel data from 2013 to 2023. So this is this data is collected quarterly, and it's panel data with total observation of 5,000 households, and it uses stratified two-stage random sampling methods. So this data set actually is collected by National Statistical Committee of Kyrgyzstan. So and it contains broad of like different types of variables that is that can be used. And to calculate drought or like climatic variables like excessive rainfall or high temperature, we will use climate data. So basically, it will be like satellite data from NASA. Semi-early warning system network and plant data simulation system with a resolution of like 1 kilometer. And so this to calculate drought, I think we will use standardized snow melt and rain index, and actually this climatic part will be also analyzed and by our colleague in this joint paper. So, and this climate data might be also some future changes. I mean, we could also choose different other kind of very like climatic satellite variables. So now I just want to show you the small descriptives, but it's like unclean data. So as I said, this KHS Kyrgyz Integrated Household data is quite large, and it needs to be cleaned first, first of all. And now we are at the stage of like preparing the data. And now I just want to show you how it's like look like. However, it's not purely clean and not for all years. So we have like quarterly data, 4 quarters per year, and we can see on the right on the right graph. So the seasonality of milk outputs. So like in winter times it's a bit lower, or spring times it goes a bit up, and then in summertime it's the highest, and then it goes again down, and so on. So this is our main output variable, let's say. We also have the fodder types that cows are consuming. So these are here the selected ones, like hay, grain, grain, fodder, root crops, or compound feeds. So we can also see these are the quarterly datas. And we also see the seasonal changes. But if we put like 10 years that we are planning, I think the graphs will be totally different. And also like after like managing the data, it will look much differently, I think. To analyze this, to answer or to understand these two research questions, we will be using a two-stage model for further input and dairy output. So as I said, I'm using panel data. So the first stage, we will be using the further input equipment. First, we will understand how droughts and other other like control variables affect fodder production for the given like for 10 years. And the second stage will be how fodder like affected by droughts or like climate risks will affect milk production. So this is like a two-stage model, and it could be also we could also like work on this approach or like improve the approach within this coming 1 month, I think, during my stage here. So the next steps. So while I'm here, I would like to really use the time for data preparation of this KHS data. I will do also specific literature review. Of course, like there will be descriptive analysis, and I would be very happy if I also manage to do like econometric modeling and to get the results. So this is actually the first part of my talk. So this was about my research plan that I'm going to do here on the first paper, on the joint paper in the SDGnexus Network project. So now I will go to the next topic, which is the role of farmers' perceptions in index insurance demand in Kyrgyzstan and Uzbekistan. So here we can also see the authors, like co-authors. So this study was supported by DAD and Klimanis project from YAMO. Yes. So the Klimanis project was initially about like index insurance piloting in Central Asian countries to increase the resilience to the droughts. And so in my research, I will be talking about behavioral part of that research. So we know that in many like countries, agricultural insurance is quite popular, but it's quite expensive for the countries like for developing countries. And the scientists also companies, they developed like index-based insurance, which could be as a promising climate risk tool for climate risk, especially for drought. So because it's quite easy, it's quite fast and relatively cheap, and it's so it's also reduces the moral hazard and adverse selection. So this is the first part, and then the main part will be about risk perception. So the literature on risk perception says that actually the climate risk perception is a precondition for adaptation measures. And it's also crucial link between climate change and choice of adaptation strategies. So farmers first, they perceive drought or like perceive any kind of risks, and then they take kind of adaptation measures. So here the risk perception literature has been working on. There have been so many studies on risk perception, but so that sometimes the individual perception of climate risks are not necessarily in line with objective risks. So, and the second research gap is that the role of perceptions, like farmers' perception on willingness to purchase crop index insurance is not well researched. So, given this background, we have like research question: how do subjective drought perceptions and their deviation from objective drought risk indicators affect farmers' interest in purchasing crop index insurance? So for that, we have three research hypotheses. So the first hypothesis is kind of straightforward, like the higher subjective drought perception is positively associated with farmers' interest in purchasing crop index insurance or kind of adaptation measures. The second research hypothesis is that farmers who excessively overestimate or farmers who overestimate drought severity are less likely to express interest in purchasing crop index insurance. And this was a bit crucial or like kind of interesting or like bit difficult hypothesis that we developed. And also, you can also see in the end. So the reason why the third hypothesis is that higher absolute misperception of drought risk, regardless of direction, is positively associated with farmers' interest in purchasing crop index insurance. So to answer these research questions and to address the hypothesis, we had primary cross-sectional survey data of 2,228 observations from Kyrgyzstan and Uzbekistan that was collected in 2021. So for the survey, we used multi-stage cluster sampling procedure on grain farming households. And to calculate droughts, like objective drought, we used meteorological data like satellite-based precipitation and temperature data from SHRPs and BILDAS between 10 years, like 2010 and 2020. And for to calculate objective drought, we used drought hazard index. So this is the study area where the surveys were conducted. So this is Central Asia, and so the white dots are like survey areas. Okay. So now I would like to talk about how we match the objective drought versus subjective drought to assess the farmer's accurate perception. So here, as for the subjective drought risk perception, we had the survey questionnaire. There was a question like, how strong was the impact of drought to your production on average? And the answers were from 0 to 5, which is Likert scale. And for the objective drought, we use the satellite-based data. So we use like drought hazard index, which calculates the drought, if there was drought or not. So, and then it was a bit crucial for us to calculate, to match the subjective and objective drought, because there are not that much manuals, for example, on the internet or like on the literatures, because different researchers, they are using different approaches, and there is not like one way to calculate the perception accuracy. And so in our case, we calculated these two variables, like we normalized the objective drought, which is here from 0 to 1, which is continuous variable. And then for this subjective drought perception, which was like a Likert scale, we also normalized it, like starting from like 0 to 1, but we didn't use like continuous variable, but we use like 0, 0.2, 0.4, 6, and then 8, and it's a ton. So how these two variables were like prepared, and then we calculated. So we subtracted objective droughts, the normalized objective drought, as you can see here, from subjective perception to understand how much the perception accuracy was. And we have also absolute misperception after that, which is the absolute value of, it's kind of like perception accuracy, to the magnitude of perception accuracy error. Yeah. So this is the result of the perception accuracy. As I said, like it's excess perception of drought in Kyrgyzstan on the right side, which is quite so. So as you can see, a little bit like some farmers were like their response were close to 0, which means they were quite stating drought accurately. But we also see the dispersion from 0 to 1, which is which indicates the farmers are overestimating droughts, and the right tail shows the underestimation, this minus values, and the plus values like kind of overestimation of drought. So so we can see here like some farmers were like the responses were close to 0, which is more or less correct, but they are also like overestimated and underestimators of drought. On the other side, for Uzbekistan, we have like three groups, I would say. So this part was, for example, perceiving like overestimating drought. Some of them were underestimating, and then in the middle there was kind of accurate perceivers. So it's like the accurate perception is less than the example of Kyrgyzstan. This is the absolute misperception, which shows the magnitude of perception error, as I said. So here we only took the overestimation and underestimated results, and it's from 0 to 1. The 0 indicates the accurate perception with objective drought. So here we can see also in Kyrgyzstan that the dispersion is like the answers, let's say, are also like kind of heterogeneous, but there are also some farmers whose statements are also close to 1, which is like correct. But on the other side, we see absolute misperception of Uzbekistan, which is highly heterogeneous, which is kind of either underestimated or overestimated. Okay. So this perception part was the main part of this research, and we used these variables as independent variables. And our dependent variable here is willingness to purchase crop index insurance, as I mentioned in the beginning. So here the results. And we have like 6 models here. The first model and the fourth model shows that only how like subjective perception influence the willingness to purchase crop index insurance. And we see that indeed, like subjective perception significantly affects willingness to purchase crop index insurance in Kyrgyzstan and also in Uzbekistan. While the next step was to understand how the excess perception affects the willingness to purchase crop index insurance. So here we see in Kyrgyzstan it shows negative value, but significant negative value. But in Uzbekistan it shows significant and positive value. The absolute misperception in Kyrgyzstan is significant, but in case of Uzbekistan it's insignificant. So here I don't show you all the control variables results, but we can also see here that agricultural education was, for example, significant, and like total land, irrigated land, awareness of index insurance, access to subsidized credits, and risk attitudes. So now I would like to explain why this happens, why the subjective perception, or like these are the 3 types of perceptions, like their effects to the index in the willingness to purchase index insurance. So as I said, like for 2, so here like for the model 1 in model 4 shows like the subjective perception was significant, and it's quite straightforward. And also the literature says like subjective perception is a precondition for adaptation measures. The higher perceived drought severity increased insurance uptake, and it was significant for both countries. But in terms of excess perception, for example, it was negative, which showed like underestimated, like drought underestimation influences significantly the willingness to purchase crop index insurance in Kyrgyzstan. And this could be explained by the fact that farmers they want to purchase index insurance even though their perception is that they underestimate drought. It's because that they kind of want to avoid future risks, or like they try to reduce anxiety, or like to avoid unexpected bad years, or like optimistic bias, which indicates like, so I don't have drought here, but my neighbor has drought, or like someone else but drought doesn't affect me, like something like that. And the misperception, it's also a bit challenging for me to kind of draw conclusion of these results, because misperception, which could be also underestimation, overestimation, it affects willingness to purchase crop index insurance. And this is the explanation could be that they are uncertain, farmers are uncertain, or they have imperfect knowledge about drought conditions. And that's why they try to also have kind of precautionary adaptation measures like purchasing index insurance. In Uzbekistan, so it's also similar, like subjective perception. It affects the willingness to purchase crop index insurance. But excess perception is explains here that the farmers who overestimate drought, they are likely to purchase crop index insurance, and it's a bit different from Kyrgyz case here. So the more farmers are perceiving drought, more they are exaggerating the drought conditions, and they are likely to take adaptation measures, or they might also take kind of over adaptation measures. And then the risk perception was insignificant in Uzbekistan. So yeah, so these are the main results. And for both countries, we also said, as I said, like subjective subsidized credits, agricultural education, land holdings, Uzbekistan, Kyrgyzstan, and irrigated lands, and risk attitudes were also significant. So as a conclusion for perceptions, so we wanted to, like, I think there should be localized drought monitoring systems, and this drought information should be disseminated regularly through internet, for example, WhatsApp, Telegram, televisions, or like village leaders to improve farmers' perceptions. So and also our study shows that awareness of index insurance in both countries were very low. And to increase the awareness of index insurance, there should be like farm training programs or extension services to increase the awareness and to strengthen farmers' risk management capacity. And for the policymakers, the index insurance should be low premium micro insurance production, insurance programs. Should be developed by the policymakers, and for the subsidized credit. So this is for the policymakers again. Like they should kind of consider bundling credit lines with insurance contracts, or there should be like they should create incentive programs in which insurance coverage reduces collateral requirements. And of course, like trust and transparency are critical to have like to success of both weather information and index insurance. So the future outlook should focus on COVID factors behind drought perception biases, because we have these results, but we should also understand what are the drivers of these perceptions, different perceptions, and why they underestimate, why they overestimate drought. So these COVID factors would be very helpful. And also we should, so I think here like to analyze how heuristic, memory, optimism, pessimism, and mental models shape drought interpretation. So in line with other socioeconomics, farm level variables. Yeah, I think that was the last slide. And thank you very much for your attention.